All right. Welcome back. So now we are going to deal with sets. So this is, what are we, in the fourth video on Module 7. Now, keep in mind, Module 7, we've got 2 chapters in here. And I combined them because a lot of this stuff is so similar and so redundant that let's just knock out both of them at the same time. And I get it. The videos have been long. This one won't be as long as the previous videos, especially the last 2. Okay. So many of the concepts that we're going to deal with here in sets are very similar to dictionaries. Let's do some rehash in case it's been a day or 2 since you watched the last video. Let's talk about the data types that we've dealt with, or the structures, if you will, because that's what these are. They're data structures. We're taking other pieces of data and storing them together. They may be the same, they may be different, but so far we dealt with tuples or tuples, whatever you prefer to use, whatever pronunciation. Tuples are immutable. We can't change them. And they can have different data types within them. There's functionalities associated with that tuple. Now, if we're talking about a list can also have multiple data types, but it is mutable. I can change it. And there's functionality that I can utilize to manipulate that list. I can use a loop, I can use a for loop, and go through it and print out what's in that list. And it can print it out, what I would say, prettier than if I just printed the whole thing out, and then we'd see it within those square braces. And speaking of square braces, that's what sets lists apart visually from a tuple. Tuple, we use commas, and we optionally can use parentheses. Lists, we use square braces. Dictionaries, we use curly braces. And now here we are at sets. Sets also use curly braces, similar to dictionaries. Now dictionaries, if you recall, they had 2 things going for them. They had a key that had to be unique, and they had some value associated with the key. I compared it to a dictionary. You're going looking for a word, and then there's a definition associated with that word. If we use that analogy, and let's think about it, there's a rule that applies. You can only have the word one time. The key has to be unique. You can't have 40 words that are all the same with different definitions. It's that one word that may have multiple values. Think about that. One unique word can have multiple values. Our dictionary, that one key, can have more than one value associated with it. We just separate them by commas. So with that said, here we are, we're in the set lecture, video, whichever you want to call it. And a set is much like a dictionary. We use curly braces. It's much like a dictionary in that it has a unique key to it, or what we see there is something's unique. It's kind of like a dictionary, we just got rid of the keys. Not got rid of the keys. We got rid of the values. Apologize for that. So we just kept the keys. So it's like a set of keys. Or the author of the text calls it a bag of keys. And the word bag comes up in other data structures. But if we're looking at this, we just think of it like it's a group of individual keys. None of them are the same. So we create it. Let's create a set. And we use parentheses here. What do we use parentheses for? To create a tuple. So let's run this and see what do we get when it's all said and done. Empty set has in it set. Well, come up here, I'm going to say print type empty set. Now let's run it again and see, and I'll put some white space in here. We're printing out empty set. I'm going to come over here. I'm going to print out set. I want to see what type that is as well. And then here we go. We've got empty set. We've got that type again. So let's see, what do we get? So we showed what was there. It's set. And it says that it's a data type set. Now, I'm seeing parentheses. I'm not seeing curly braces. We'll get there. We'll get there. This is creating an empty set. That's exactly what it is. That's using the set function. So that set function created an empty set. So we see it's a typecasting of sorts. So we created a set, we passed it nothing, it gave us an empty set. We then created, what did we create here? Even numbers. We created even numbers, and it's in curly braces. Well, curly braces can be one of two things. Curly braces can mean it's either a set or a dictionary. Think back to dictionaries. What did we have in dictionaries? We had a key and we had a value, and they were separated by a colon. I don't see any colons in here. So since we don't have those things paired up together, that means this is a set. So by definition, we're creating something using curly braces. That means it's one of two things. The fact that we don't have colons in here, or we don't have a key equals and then a value, we'd have to have one of those two things for it to be a dictionary. We don't have either of them. So that means this is just a set of values, or like the author called them, keys. We've got things stored in this set. Now, they're stored in here in numeric order, aren't they? And they're displayed in numeric order. What happens, let's get this out of the way right now. What happens if I do that? Will it print out the same way? See what just happened? I declared this thing as 04268. If we were dealing with a list, it would be printed out exactly the same way, because we have those indexes of how we stored. It's almost like we had, and if you think back to the analogy I used, it was like we had a line of storage units. Here's storage unit 0, storage unit 1, storage unit 2. each one had a position or an index, and I went and put something in it. That's not what's happening here. It's not what's happening here. That descriptor or visualization or analogy that the author used to call it a bag of keys, it's going to make sense now. We just throw these things in a sack. We throw them all in a bag. When we declare it, we throw them all in there. And when the time comes and I need to get what's in there out, it's like magic. Something's happening in the background. I don't have to do it. It happens for me. But what it does is it takes whatever I've thrown in there and whatever order it's in, and it orders it for me. Okay? So keep that in mind. Doesn't matter how you put the things in there, what order you put them in, the system will set them in their correct order when it stores them. So when you go to get them, they are in a specific order. Now, if I want to convert something from, we've got a set here. We declared a set and we passed it a string. It's a string literal constant. And in that string there are 7 characters. We'll call them letters. So we've got this set. We passed it a string. Now, you think back to what we did up here. These were all unique values. These are not. These got ordered when we did our thing with them. When we declared them and initialized them, they ordered them for us. Something else took place, but we didn't see it. I'm going to show you right now what happens if I give it 2 4s. How many 4s do you see in there? Just 1. I can give it multiple values that are identical. It's only keeping the unique ones. So when I say there's some work going on behind the scenes, that it ordered it for us, it got rid of duplicates for us, this could be a tool that we could use in the future. If, you know what's in that list? What do I have here in this string? Go ahead and get rid of duplicates and let me do it all at once. Instead of having to use multiple individual functions to perform that work, and converting this thing over to a set does it for me. It orders it and gets rid of duplicates. Okay. So on this conversion, we're converting this string to a set. We're going to pass those in. The system looks at it. It's functionality built into this set function. And it says, wait a minute, we've got duplicates. Get rid of the duplicates. We only want the individuals. And here, we're not in alphabetical order. We're not in alphabetical order here. The numbers, we were. The letters were not. All right, don't worry about that one. It's little things that will come up. But for this one, the E is not where we would think it would be. And that's the only one that's getting thrown off, is the E. But wait a minute. Is it ordered? In a way it is. In a way it is. So what's happened is, as this thing went through, it ordered them, but it's as it reads them. So if I go back here, I take this and I move it back to the end, is it going to be the same? Wait a minute. What happened there? I got the 4 before I got the 2, but now the 4's after the 2. It's all about where, if it's got more than one, it's where it reads the last one. Where it reads that last one, and it got it where we wanted it. Do it here again. Here it is there. On this, on the letters, went through and it read L. I said, all right, put that L in there. Put the E in there. I put the E in there. Put the T in there. Huh. All right, I'll put the T in there. So we've got an L, an E, and a T. Okay, let's assume we've got that L, E, and then the T. I'll type it in here. So we've got those. That's what we've stored in there so far. And we're going through this bag. And we're going through these letters and working with them. I got another T. Just ignore it. I got another E. Oh, all right. I got another E. Well, I've already got an E. And in theory, I'd put that E there and get rid of this one. It's like, wait a minute. This is not coming out like this. So this thing's not ordering it the way we would assume that it's going to order it, the way it ordered numbers. So it's looking at something other than what we would traditionally look at as an alphabetical order here. Some other value of how it's ordering what's going in there. Okay. Let's come on down. We've got a set. And here we go. There's our items. And wait a minute. These are strings. Now these are alphabetical. Yep, they are. Let's go to some more strings. They're alphabetical. That's starting character. Let's go ahead and put some other strings in there. But no, wait, these aren't strings. What's that symbol identify? That symbol identifies this is a dictionary. So I'm passing a dictionary to a set, typecasting a dictionary as a set. Difference between a dictionary and a set. Dictionary has keys and values. Sets only has keys. So the values went away. We just kept the keys. That's what took place. We can get the length of the set using the len function. We can add something to it. So I defined it as 1, 2, 3. I'll add 4 on there. Tax it on the end. I can use a remove function and pull that item out, much like we did pop. Okay. We can use a for loop to navigate it. For piece in furniture. I can call it for item in furniture. Same logic that we've used on those other structures. And it goes through it, item by item. Prints it out. We can check to see if a value is in a dictionary or if it's in a set. So I created this dictionary. And if I take this dictionary and I want to go through it, for name, comma, contents in drinks.items. I'm navigating this dictionary. So we did this before, drinks.items. So it's looking for contents in. Let's say, instead of contents, let's just say items. For items in drinks.items, if vodka is in items, print name. For name, comma, contents. Name, contents. Okay? So we're looking for vodka. Is this the way it's going? Name, contents. Name, contents. Name, contents. Name, contents. So we're looking for the name. We want to return the key. Looking for something in the value. That's essentially what's happening. So this is with a dictionary. We're going through and we're getting it. And we're testing to see if vodka is in the values. And as we said before, in a dictionary, unique value, unique key, multiple values. Just like one word can have multiple definitions. Now, one of the last things we're going to deal with, and it's like I said, this is probably going to be the shortest video in this module. We've got operators to compare things, to combine things, and we can use this operator. Okay. We can use this operator to look at two things. It's a combined test of this and this. Now, this is the AND operator. And in some languages, it's spelled out A-N-D. Here we're seeing just one. In another language, we may have two of them together for that to be the AND operator. If contents and this, print name. So if contents in drinks, contents, let's go print, see what it prints out for us. Contents and, so we want to see if contents is the same as vermouth and orange juice. So if the contents have orange juice, and we want to find vermouth, and there's vermouth, we're looking for those two items. So we're looking to see if contents contains these things. And that we're going through each of the values looking for them. And there's what we end up with is the names associated with those items. We're going to have a for loop where we're going to run through this thing and we're going to find out if vodka is in the contents, but we don't want to find vermouth or cream. Oh, wait a minute. Black Russian, does it have cream? Black Russian, no cream. It's the White Russian that had the cream in it. So we used an and a not in here. And we're also using that operator again, where contents has these items. Now, we're not going to dig deep into this. Like I said, this I'm going to just go over very shallow. And that's, I'm not going to dig deep into this. Just know that we've got these different options when it comes to comparing these things. I can create a set and put in it 1 and 2. I'll create another set 2 and 3. Print A. Now if I did that, A is 1 and 2. Am I limited to just numbers in there? No. And look, it went and it put Jim ahead of the numbers. It's ordering it using whatever criteria it's using to order. Comment that out. Here we come back. What is the intersection of A and B? Intersection means what's in both. 2 is in both of them. It's the intersection of those two. Oh, I didn't run that. There we go. I defined them. What's in both of them? Russian. Oh no, vodka. Yep, I gotcha. I forgot about that. This is coming back off of the drinks up above. And we're going in and we're getting what values are in those keys. This next one is the union. We combine them together and we get rid of duplicates. Okay. Since 2 is in both, this is what's in them. So we don't have 2 twice. What's the difference between the two? Well, the difference between A and B is A has 1 and B doesn't. They both have 2. So this is the unique item in A. It's the difference between them. Cream is the difference. Now we did both of them. It would have come up empty. If I printed it, there's nothing unique about one, and cream is unique about the other. We run this one, the symmetric difference between A and B. What do they not have in common? It's essentially what it means. What items are not in both of them? 1 and 3. We talk about a subset. Is A a subset of B? And is A a subset of A? Well, let me go ahead and I'm going to put the print statement in there so we see all of them. Because what this is doing is just giving us the last one. And don't forget, it's got to be a lowercase p. Let's run it again. Now we've got all 4. Is A a subset of B? No, there's things in A that are not in B. Is A a subset of B? Now, there's 2 ways of looking at it. One is the comparison operator. The other is a function. Comparison operator, function. A set is always a subset of itself. Yes, everything in A is in A. Right. And then we'll go do the same thing. Over here. Well, let's run that one. Straightforward. Is it a proper subset? No, it's not a subset at all. Now, this one, we use that less than symbol. Okay. Superset is it's the opposite of a subset, meaning does it have more things than the other one? And it does have more things than the other one, but the other one, well, I shouldn't say it doesn't. It would have to have everything that's in B and then some. Well, it doesn't have 3, so that's where the issue is. It's always going to be a superset of itself, though. Okay. And here, let's wrap this wrap up sets and get this behind us. Feels like this module's gone on forever. So with this one, we can use the frozen set function. Pass it something, pass it a list, we can pass it a set. It then takes whatever I passed it and it converts it into a frozen set. Frozen set differs from a set in that a set is mutable, a frozen set is not mutable. So each one of these, it took it, it ordered it for me. They went in all differently. Every one of them is a frozen set. So if I went and did type on it, it'll come up that here this is a set, but it's frozen. So it's special in that, let's go test this, see will it make it immutable, see if it is immutable. Or so we take the frozen set, we pass it a set, I then store it in FS. So print FS. Let me take this last line here, and then I'm going to say print type FS. Let's run this and see what we end up with. We have a frozen set of 1, 2, 3, and what class is it? Frozen set. So it's, if we back up, and I've talked about this before, a class is the code that we're dealing with, and we create an instance of the class. So we create an instance of a set, and we call it whatever we want. We create an instance of frozen set, and we call it FS. So all the rules to the game, all the functionalities and attributes and everything associated with that class, they're inherited by this object I've created. And I pass that object over to print, and print says, here you go, this is what your object is. This is what you've got in there. And I said, what data type is that object? Frozen set, that's the class that was created from. Now, the class that we use to create our objects, whether it's an integer class, whether it's a float class or a double or whatever the language may be, we're creating instances of these classes, we're creating objects. We're limited to whatever functionality is associated with that class. And since we're dealing with a frozen set class and not just a set, the frozen set class does not have an add function built into it. It doesn't. So it's not going to let us do what's there. Because it's going to tell us frozen set object. The object is an instant. The object is FS. It's our instance of the frozen set class. It has no attribute add. An attribute meaning there's no function called add. We don't have anything in there like that. They're telling me to use something that we don't even have that built in. So it's not built in for a reason. But if I wanted to come up to my set and I wanted to add something to it, we did that. We did that up above here. I removed and I added right there. I added using the add function in the set class. So I'm limited to whatever functionalities exist. I'm limited to, I like to say, the rules in the game. All right. So there's a couple things that I'm going to talk about real quick, and then we're going to, you know what, I'm going to talk about them in the next video. I'll hold off for now. So this quick review, we'll pick up that quick review in the last video, and the last video is going to be quite short. So go play with this exercise, go play with this notebook, and I'll have more things in here to play with. And I'm going to start adding in blocks of code for you to go and debug, find the errors. Look at it like a seek and find kind of thing. There's an issue in there, go find it and fix it so that it runs right. Okay. That's a good exercise. The better you get at it, the better of a programmer you can be, and the better understanding you have of looking at things analytically and breaking them down into their components. Right. So we'll see you in the next lecture.